friends, welcome to our channel. In previous video we discussed about interior and closure of a set in a metric space. In today's video we will discuss about subspace of a metric space with some results. Subspaces of a metric space. Let XD be any metric space with metric D. Suppose Y be the subset of capital X and D star is induced metric on capital Y by metric D, then the metric space YD star is called subspace of the metric space XD. D star XY is equal to DXY for every XY belongs to capital Y. Let XD be a metric space. Y is a subspace of subset of capital X and Y itself a metric space with the metric D star where D star is equal to D star XY is equal to DXY. That means D star is restriction of D on Y. So the YD star becomes the subspace of the metric space XD. For example, let R be the set of real numbers and D is usual metric on D. That is RD is a metric space. We know that Q, the set of rational numbers, is subset of R define a metric D star on Q as D star xy is equal to dxy is equal to modulus of x minus y for every x y belongs to Q. Then Q is metric space with metric D star. Thus Q becomes the submetric space of the metric space R. Now we will discuss some results based on submetric space. So theorem: let XD be a metric space and YD star be the subspace of XD a subset B of capital Y is D star open if and only if there exists a D open subset G of capital X such that B is equal to G intersection Y. In this theorem, XD be a metric space and YD star be the subspace of XD. That means Y is a subset of X and D star is induced metric by metric D. A subset B of capital Y is D star open. That means open subset in Y. D star opens means the open set in the metric space Y. And D open means the open sets with metric D in capital X. We have to prove that B is open in Y if and only if there exists an open set G in X such that B is G intersection Y. Proof. Let XD be a metric space and YD star be the subspace of XD. That is, Y is contained in X and D star is induced metric by D. That is D star xy is equal to dxy for every xy belongs to capital Y. Let sphere centered at y0 with radius r star be the sphere centered on y0 with radius r in y. Y is a metric space with metric D star. Therefore, any sphere in Y is denoted by star. So, SR star Y0 be the sphere centered on Y0 with radius R in capital Y. So, SR star Y0 is equal to Y belongs to capital Y such that D star Y0 is less than R. This implies SR star Y0 is equal to Y intersection SR Y0, where SR Y0 is open sphere in X with metric D. That is, any open sphere in Y is also a open sphere in X because Y is a subset of capital X. Now, let B be any open set in capital Y. We have to prove that there exists G open in X such that B is equal to G intersection Y. As B is open in capital Y, so B is neighborhood of all its points. Let Y is belongs to B, then B is neighborhood of Y. So there exists sphere centered on Y with radius R1 is contained in B. Because B is a subset, open subset of Y, so sphere centered on any point of B is denoted by star. So SR1 star Y is a sphere centered on Y with radius R1 is contained in B. We know that in metric space, every open set is union of open spheres. Therefore, B is equal to union SR1Y star such that Y is belongs to B, which is equal to union Y intersection SR1Y such that Y is belongs to capital B, because SR1 star Y is equal to Y intersection SR1 small y, where SR1Y is open sphere in capital X, which is equal to Y intersection union of SR1Y such that Y is belongs to capital B, which is equal to Y intersection G, where G is equal to SR1Y union, that is G is union of open spheres in capital X with metric D. This implies B is equal to Y intersection G. Conversely, suppose B is equal to Y intersection G, where G is open in X, we have to prove that B is open in Y, that is B is D star open. Let Y belongs to B be arbitrary, then Y is belongs to Y intersection G, because B is equal to Y intersection G. This implies Y is belongs to capital Y and Y is belongs to capital G. Since G is D open, so there exists a sphere centered on Y with radius R1 is contained in G. Hence, SR1Y star is equal to Y intersection SR1Y, which is contained in Y intersection G, which is equal to B. So Y is belongs to SR1 star Y is contained in B, Therefore, B is neighborhood of Y, but Y is arbitrary point of B. Therefore, B is open in Y, that is B is D star open set. Next theorem. Let Y D star be a sub-metric space in order to prove every open subset capital B in capital Y be open in capital X. It is necessary and sufficient that Y be open in X. In this result, it is given that XD be a metric space and YD star is a subspace of metric space XD. We prove that every open subset B in Y is also open in X. We have to prove that Y is open in X. Proof. Let XD be a metric space with metric D and YD star the subspace of XD. Let every open sphere open subset B of capital Y be also open in X. Since capital Y is open in capital Y, because we know that phi and full space is always open, that is capital Y is open in capital X. Conversely, let capital B be open in capital Y and let capital Y be open in capital X. We have to prove that B is also open in X. Since B is open in capital Y, so there exists an open set G in capital X such that B equal to G intersection Y. G and Y are open in capital X, therefore G intersection Y is also open in X, because union of open set is again open. This implies B is open in X. Next theorem. Let YD star be a subspace of a metric space XD and let capital A be the subset of Y, then the subset A of Y is closed in Y if and only if there exists a class set H in capital X such that A is equal to H intersection Y. In this theorem, it is given that XD is a metric space, YD star is a subspace of XD, A be any subset of Y, A is closed in Y if and only if there exists a closed set H in X such that A can be written as the intersection of H and Y. Now the proof. Let XD be a metric space and YD star be the subspace of XD. let A be any closed subset of Y. As A is closed, therefore Y minus A is open. So Y minus A is equal to G intersection Y, where G is open in capital X. This implies A is equal to Y minus G intersection Y. This implies A is equal to Y minus G intersection Y minus Y. This implies A is equal to Y minus G, because Y minus Y is equal to 5. This implies A is equal to Y intersection G complement. This implies A is equal to Y intersection H, where H is equal to G complement. As G is open in capital X, therefore G complement is equal to H is closed in X. Conversely, if A is equal to Y intersection H, this implies A can be written as Y intersection G complement. This implies A is equal to Y minus G. This implies A is equal to Y minus G intersection Y minus Y. This implies A is equal to Y minus G intersection Y. Hence, A is closed in capital Y. So, there exists H closed in capital X such that A is equal to H intersection Y. Next result, let XD be a metric space and YD star is subspace of XD, and let A be the subset of capital Y, then A star closure is equal to A closure intersection Y, where A star closure and A closure denotes the D star closure and D closure respectively. of A contained in Y. In this question, XD be a metric space and YD star is a subspace of XD. A is any subset of capital Y. Then according to the metric space Y and with metric D, there exists a closure of A denoted by D star closure. And A is a subset of Y, therefore A is also a subset of X. And X is a metric space with D. So A closure is denoted D closure in capital X. Proof. Let XD be a metric space and YD star be the subspace of XD. Let A be the subset of capital Y, that is A is contained in Y. A star closure is the intersection of all D star closed sets containing A, that is A star closure is equal to intersection H star such that H star is closed in Y and A is contained in H, which is equal to intersection H intersection Y such that H is closed in capital X and A is contained in H intersection Y, which is equal to intersection H such that H is closed in capital X and A is contained in H intersection Y, which is equal to A closure intersection Y because A closure is intersection of all closed sets of X containing A. This implies A star closure is equal to A closure intersection Y. It is sufficient for today. In the next video, we will discuss the sequences in metric space and the convergence of the sequences in metric space. So keep in touch, watch our videos, subscribe our channel for more results Thanks to all. Have a nice day. Bye bye.